Hello, you are welcome to this video. Now in this video is going to prove that sin theta times sin 2 theta is equal to cosine theta minus cosine 3 theta all over 2. Now, before we start proving this, there is an identity that is given as sin of A times sin of B to be equivalent to the cosine of A minus B minus the cosine of A plus B all over 2. So we can easily make use of that and apply this here in this manner. Okay, since we have that cosine A minus B minus cosine A plus B, okay, all over 2. That we have sine A times sine of B. That this is what we're going to have from that identity. Okay, so we can just easily say, okay, when the A is theta and the B is 2 theta, if we plug that in here, you're going to have something like cosine of negative theta minus cosine of 3 theta. And you know that cosine is an even function. So the cosine of a negative angle is the same thing as the cosine of a positive angle. So because of that, we just arrive at cosine of theta minus cosine of 3 theta all over 2. Okay, so it's very simple. We've proven using that identity. But we are not going to use the identity here. Since this is a particular question, we just solve it at once and we get the result. So watch to the end of the video and look at the steps we use. It's very simple, okay? A few minutes to be done. All right, now let's start solving this. Let's use the left hand side to solve till we get the right hand side. Now take note that this is sine theta times sine 2 theta. Okay, given that sine 2 theta equals to what? Sine theta is equals to 2 sine theta cosine theta. So we're going to apply it here, okay? Place of sine theta, which is this. So applying that, we have here sine theta times, now in place of sine 2 theta, you put 2 sine theta cosine theta. So you have times 2 sine theta cosine theta. All right, now we are good. Okay, so let's just multiply this out. No, that will become 2 sine of square theta times cosine of theta. Okay, so you know from your identity, your basic identity, that sine square theta is the same thing as saying this is the same thing as saying sine square theta is 1 minus cosine square theta. Okay, yeah, so we put that in times cosine theta. So we're going to multiply this out. Just keep watching. So we have 2 times, okay, so multiplying cosine theta times 1, cosine theta times this first, and now go on to this. So that will give us cosine theta times 1, okay, cosine theta times cosine square theta is negative cosine of cube theta. All right, so doing this, we've arrived at a point. Okay, so at this point, I would say let's multiply the 2 out. So multiplying through by the 2, I will have 2 times this, that is 2 cosine theta, okay, times 2 negative 2 cosine cube theta. Okay, so we reached a certain point. Now, what is cosine cube theta? We still have to evaluate this. Take note, we are heading there. So we continue. Now, our emphasis here, look, we want to note what is this cosine cube theta, okay? Because if I substitute something for it, okay, I'm going to solve this and get it. Now, there is this expansion of the cosine rule, of the cosine, sorry. So cosine of an angle, or yeah, cosine of 3 times theta, okay, would be equal to, you have it there, 4 cosine cube theta minus 3 cosine theta. In your complex numbers, if you do this, equating the imaginary parts together, you have that cosine of 3 theta is equal to 4 cosine cube theta and minus 3 cosine theta. If you understand this, our next video, we've done something on this. So, having this, we make cosine cube theta subject of formula here. We're going to have cosine of 3 theta minus, that is plus 3 cosine theta. Okay, making cosine cube theta subject of formula, we divide it by 4 equals to cosine of cube theta. So that could be a value of cosine cube theta. So from here I have 2 cosine theta, okay, minus now 2. Okay, so in place of cosine of cube theta, this I put this. Okay, so putting that in its place, let's bring this down. I'll become, we have 2 cosine theta minus 2 times, okay, so bring this, we have cosine 3 theta plus 3 cosine theta over 4. All right, so we can multiply this. We have, we have here 2 cosine theta minus cosine 3 theta plus 3 cosine theta over, these two cancel this 4, so we left with 2 here over 2. Okay, so let's find the LCM. So taking the LCM of these two fractions, of these two denominators, 1 and 2, we will have 2 here, 2 be the LCM, so we multiply through by 2. That will give us 4 cosine theta minus cosine 3 theta plus 3 cosine theta divided by 2. It's beginning of low rate, right? Okay, so from here we will get to, all right, for letting like terms, we would have 4. You have 4 cosine theta. Sorry, this was actually bracket. Sorry for that. So, this was actually bracket. So you have negative there. So minus 3, bracket of that. That will become negative and positive. So minus 3 cosine theta, right? Minus 3 minus cosine 3 theta. Okay, divided by 2. All right. Now evaluating this, 4 cosine theta minus 3 cosine theta is what? It's cosine theta. 4 minus 3 is 1. So 1 cosine theta, that's cosine theta. Minus cosine 3 theta. Over 2. You see something here? This and this are the same. Okay. So, very simple, right? Just keep on with your sign of double angles, go on with it, evaluate normal algebra in trigonometry here. So we get to a point, and this is what we're looking for. Alright, if you find this video helpful and you like the video, please subscribe to this channel, stay connected. And besides, this particular question, this thing, cosine 3 theta, we're going to prove it in our next video. So subscribe to our channel so that you'll be notified when we post any video. Thanks for watching and have a nice time. All right, so that's it.